Hello everyone, a very warm welcome to this video. In this video, we are going to talk about how do we create a small mini cluster on a desktop. Basically, let's say having two VMs and creating a quick cluster. Now the minimum requirement for this particular lab is 8 to 12 gigs of RAM. So let's get going. So first let's understand what are we trying to achieve with this particular lab. So as of now, we have a base OS which can be Mac or Windows. That's immaterial. On Mac or Windows, we are running two virtual machines. Both CentOS. And on both the machines, Hadoop is installed, and the way it looks right now is so on both the machines we have Hadoop up and running. Now the agenda of this particular lab is at the end of it, we'll have no slave services on machine 1 and no master services on machine 2. And we will educate the machine 2 that machine 1 is the master. So this becomes slave and this becomes master. That's the real goal of this particular lab. By the end of this lab, we will have one master, one slave, and slave would be pointing to the master. So let's get going. So navigate to page 19 of this particular PDF. Now the first thing we need to do is, because we are changing all the configurations, we should stop all the services. And during the lab, anytime if we have to restart the machine, we will again have to stop all the services because we are making some configuration changes. So one thing to remember, anytime you restart the machine, you will have to stop Hadoop services when you're doing a configuration change. So let's first stop all the services on both the machines. So on both the machines, services are going down. Now to understand step number 2, 3, 4, we will have to understand an interesting concept in Unix called as alternatives. So let's understand that. So on this machine, all the services are down. Same here. Now, every software that you have actually has two components. It has a source code and it has a configuration. And the source points to that particular configuration. Now configs can come from database or can come from config files. Now the idea is, let's just say that price of a flight ticket from San Francisco to New York, will that be part of your source code or will that be part of your configuration? It will be part of our configuration. Though it comes from a database, it's still configurable. Now, Very similarly, Hadoop points to a configuration. But with alternatives, the facility is that we can have multiple configurations and we can point to any one of them. So in Hadoop's context, the source code is nothing but Hadoop code. And as of now, Hadoop is pointing to a configuration called as conf.sudo. Conf.sudo, the dictionary meaning of sudo is false. Now, as of now, what we are running is a false cluster because our single machine is the master and the same machine is the slave. So it's nothing but a pseudo cluster setup. We also have one more configuration given by Hadoop that's called as conf.empty. So this could be used as a template for the new configurations. Now, what we are going to do is we are going to copy empty to a new configuration called as conf.multinode, and we are going to point Hadoop to that particular configuration. Once Hadoop starts pointing to this new configuration, which is right now empty, we will fill the configurations. We will start master services on the master, slave services on the slave, and we will have a cluster setup done. So let's get going. So in step 2, we are copying the empty configuration to a folder called as multi-node. Let's run the same command here. Now, technically, multi-node is just a folder. We haven't given it the status of a configuration. So we will now have to give alternatives and information that multi-node is our latest active configuration. So let's do that. So we are installing So we've successfully installed this new configuration called as conf.multinode. Let's verify that. So what we see is that link currently points to etc hadoop conf.multinode, and the current best version is conf.multinode. At this moment, what we really have in our setup is a new configuration called as multinode, and that's active. Yes, as of now, this is empty. Now let's replicate this on the second machine also. So what we see is it's etc hadoop conf.multinode. Now on both the machines, multinode is the active configuration, though it is empty, but it is active right now. So it's time to fill that configuration. But before we do that, let's understand a small concept. Now in real world, when you set up a cluster, if a machine goes down and it comes back with a different IP address, it's gonna be a problem. That is why in Hadoop, when we set up clusters, we use host names and not the IP addresses. So it's time to give these two machines a host name and update the host file so that they both know each other. Once we do that, we'll have to restart the machine, stop all Hadoop services and update the configuration. Now let's do that. So we'll first update the host file. And that's our name node. That's going to be our data node. So quick verification. 172.16.146.191, you will have to put your own IP address, that's name node. 172.16.146.244, that's your data node. Let's SCP this file to the other machine also. Just for precaution, let's verify if it's done. So we have both the machines now. Now it's time to change the host name. Now that we've committed that our machine name is going to be name node and data node, let's change them right now. And it's time to restart the machine. Once we restart the machine, we will have to shut down all the Hadoop services again. It's gonna take a couple of minutes once we restart the machine. So after the machines get restarted, we will have to update the Hadoop configurations. Hadoop majorly has 4 configuration files that we need to update: codesite.xml, hdfssite.xml, mapwritesite.xml, and yarnsite.xml. We will update all these 4 files right now. Once we have all these 4 files updated, it will be time to create some directories and we will be on our way to set up the multi-node cluster. Let's wait for a minute. Machines are still restarting. Let's look at the machines. It's still one machine is up. Let's look at the other machine. Even other machine is up and running. So let's log into these machines. So while we restart, the first thing we'll have to do is start the SSH service. So let's do that. Let's log into the machine. And here we go, it is name node. And here we have data node. So before we proceed further, we are going to restart the services. So it's time to shut down the services once again. We are going to quickly verify that if the cluster is up and running, and we are going to run a simple MapReduce program. Let's get going. So to verify if name node is up or not, we simply run a command that says name node 50070. It's not. So what we see is that the name node is up and there is one data node here. We can see the file system from here. So have user, training, and so on and so forth. So this testifies that name node and data node is up, and this is the URL that tells you that the resource manager and node manager is up. Here we have one active node. So it's time to now run a sample MapReduce program. So let's do that. Let's create some input data. Let's dump some files. We have to give the destination. So we have dumped some data. It's time to run a program. Hadoop jar user lib Hadoop MapReduce Hadoop MapReduce examples dot jar input output. grep is the main class, and we are here to search for anything that starts with DFS followed by A to Z dot. So the program gets submitted to the cluster. And the program starts. So in a couple of seconds, we'll see that the program completes. You can verify the output. And there we can see so what we've seen is these were all the strings that were starting with DFS. So that testifies our cluster is 100% up and running. Thanks for watching this video.